Hi everyone. Today I want to talk to you about something super important when it comes to building reliable systems, and that's incident management. But before we get into the guts of this, I want to share a story with you. On August 1st, 2012, what's now become a very notorious story within the DevOps and technical communities, one particular organization experienced an outage that to the tune of about $163,000 every 7 seconds really caused some problems with their organization. A lot of you may be familiar with this story of Knight Capital. Knight Capital had what amounted to about a $440 million glitch that ended up costing not only the company a lot of money, but ultimately put them out of business. Now, this was obviously a very, very bad bug and very bad problem for the organization, but there's lots of things that they could have done to probably mitigate this and make it a little bit better. And a lot of that leads into what we were going to talk about today. So, the point that I want to make here early on is no matter what we focus on, no matter what we do, the computers that we are building, the logic that we're writing, the software that we're putting together is always going to do what we're telling it to do. So it's not really a matter of if things go wrong, but really when things go wrong. And so the question that you should be asking yourself is, how will you respond when something breaks within your system? My name is Jason Hand, and I'm a senior cloud advocate here at Microsoft, and I'd love to be able to talk to you about what I think are the important concepts around building a minimum viable incident response plan. Before we get started in that, though, I think it's important to sort of level set on some language that gets used around a lot within our industry. And the first one I want to start with is complex systems. There's a really great framework out there known as the Cynefin framework, which I use all the time to help people understand better what complex systems really are and their properties. I would like for you to go check this out on Wikipedia and learn more about that, but just for a high-level overview, what the Cynefin framework does is sort of simplify our systems into both ordered and unordered systems, and then sort of helps you understand within the different boundaries of these systems, what are the properties and what are the behaviors. So if we talk about the Cynefin framework in a little bit more simple way, I want to focus on what we see here as the complicated systems and the complex systems, especially within the complex system. And what this illustration is trying to teach us is that when there is something wrong within a complex system, we first must probe, then sense, and then respond. And so those are kind of the three things that we talk about within incident response within complex systems. One of the things we know about complex systems, especially if you're responsible for keeping them up, is that failure is unavoidable. We've all seen the dumpster fire, we've all had to respond, we've all had to troubleshoot, and we've all had to figure out what's going on to get our systems up and running again. Now, back in 1998, a gentleman named Richard Cook, Dr. Richard Cook actually, presented to us this white paper that in just 7 pages put the entire technical industry on its head. And one of the things that came out of this paper that most of us really hadn't stopped to consider is that the idea of controlling and adding additional processes does not actually help prevent incidents. In fact, it sometimes actually creates more problems. Responding to incidents has just become part of the job. We've all had issues, we've all had to respond to it, whether it's an official capacity or not. We all know that technology isn't going to work perfectly all the time. And a lot of the things that we try to teach within the DevOps community and share here at Microsoft is that some of the things that we try to teach about incident response isn't necessarily technical. There's lots of tools, there's lots of procedures and lots of processes, but there's also a lot of things that we can be learning from other industries, especially from the human factors and system safety industries. On top of that, there's so much that we could be learning from fire and rescue. They've been responding to incidents and problems for a long time. Okay, now that we've all agreed that there's going to be problems, there's going to be some sort of issues with our system, what do we do from here? One thing I'd like to hopefully get across to you right now is there's a huge difference between reacting and responding to incidents. What we really want to see is actually a response. When everything becomes reactionary and it's just a knee-jerk sort of behavior to systems, everyone's running around, it feels very chaotic, and it takes actually a lot longer to recover from incidents. Also, when we're talking about building resilient systems, although we can add lots of different monitoring, lots of different technology, and we can put lots of control and process in place, resiliency is actually something that comes down to the people part of the system. One of the things that we talk about a lot in site reliability engineering and DevOps is this idea of the hierarchy of reliability. in which we start with, at the bottom, monitoring, and then move on to incident response, and then into our post-mortem and incident review process. And then from there are more things that we consider. But at the bottom, it's all about monitoring, followed by what are you going to do when you detect an issue? And that's what we want to talk about today. So if we're going to talk about incidents, why don't we get into a little bit of the guts about what actually is an incident and what are we supposed to do under certain situations? It turns out there's actually an entire life cycle of an incident. When you start to break down all of the things that happen between noticing there's a problem, actually recovering from the problem, and trying to improve from those problems, you can start to put them into their own distinct different phases. So let's go through each of those. The first one is the detection phase, which, as you can probably imagine, has mostly to do with building observable systems that can monitor what's going on with both your applications and your infrastructure. This is essentially the first phase of an incident. Hopefully, we've got some tooling in place. Our applications and our infrastructure have telemetry that's telling us whether things are going well or not. And notifications are being fired off to the right people so that they can actually do something about it. That takes us into the response phase. The response phase is where someone, a software engineer typically, is going to acknowledge their awareness of these issues. This particular engineer also knows that they are specifically on call during this point in time. And what they do at this point is actually begin to troubleshoot and triage and try to understand through different methods of diagnosis what's actually going on with our systems. From there, they formulate theories around what should we do next? What are the remediation steps that are going to bring the system back up, or at least recover from whatever problems we're experiencing? That takes us into the remediation phase, where we're actually doing different actions and different tasks, whether that's running scripts, whether that's rebooting servers. It doesn't matter, but this is the remediation step where things are taking place to actually restore and recover services. Then we move on to the analysis phase, which is actually one of the more important parts of the entire incident lifecycle. In the analysis phase is where we retrospectively go through and discuss the timeline of events, starting with when did we know when there was a problem, all the way to when we actually recovered from our issues. And in this analysis phase, we look for opportunities for actionable improvement. Not just what can we do technology-wise to improve our systems, but also what can we do on the people side. What this allows us to do is it sets us up to understand a little bit more of, quote, how the system actually works. There's so much that goes on, especially when you talk about the engineers and the things that they're thinking and doing when they're responding to incidents. And that takes us to our readiness phase. In the readiness phase, we focus on different ways that we can reduce the unknown unknowns within our system. And that means we look across the people, the process, and the technology and see what we can do to learn and improve all of the different things that we do to maintain our systems. From there, we implement those work items and see what we can do to build a more resilient system. So if we start looking at each of these phases individually, the goal will actually turn out to be how can we shorten each of these phases? If we shorten each of the phases, then we shorten the entire incident. So if we look at this in a graph, we can see the first three phases of an incident: detection, response, and remediation. In this example, it took us 15 minutes to even know that there was a problem. Only 7 minutes to sort of coordinate our people and triage and understand what was going on, but then an additional 33 minutes to actually run the scripts or whatever it was to restore our service. So through the entire incident, we can see there was a lot of time that elapsed, and you can look at them in different ways. If we look at the first phase, the detection phase, that's all about monitoring. How can we improve our monitoring? Well, there's a lot of tools out there. Azure, of course, has a lot of great monitoring, application insights, log analytics, all kinds of tools that can help you create a more observable system. But there's also some really great open source and commercial tools available to you as well. Here are a few that I think you should check out. Then we move on into the response plan. In the response plan, we actually start to set up concrete ideas about who's going to be doing what in certain situations. And here are some tools that I'd like to share with you when it comes to coordinating your on-call response plan. Azure Monitoring has some great stuff when it comes to setting out alerts and responding with troubleshooting guides. But if you need to set up some other more deeper tooling, I would suggest VictorOps, PagerDuty, or OpsGenie. First, let's talk about rotations. On-call rotations are super important to establish who is actually going to be responsible for problems when they come up. Now, there's lots of different ways you can set up rotations. You can, of course, just set up a standard rotation, which could be something like 24 hours a day for several days out of a week, or maybe it's just several hours for a few days a week. There's lots of different ways you can set up just a standard rotation. It's a good starting point, And it's also an easy way to sort of get things going if you're not used to doing actual response plans. The next one that a lot of teams use is called follow the sun. Now, follow the sun is great when you have multiple shifts. This allows distributed teams to actually only have to take on-call responsibilities while they're on their office hours or while they're at work, which is really great to be able to sort of not disrupt people's home lives and their personal lives. Then, of course, you can get customized from there, and you can do all kinds of things which become very, very helpful when you've got complex scenarios. Maybe you've got things going on the weekend. I'm supposed to be on call, but yet something's come up. There's a lot of different ways you can do some custom different things. But at the end of the day, all we're doing is establishing who's on call for what kind of problems. Okay, so let's talk about some of the roles of being on call. The first one I want to cover is the primary on call. The primary on call is the first person who's going to respond to an incident. Then we've also got secondaries. Secondary on-call engineers are pretty much our backups. So when the primary on-call engineer responds to an issue, if they're not sure what to do, if they get stuck, they know who the backup person is, or their secondary on-call. It's also very common for companies to use incident commanders whenever they have a wide-scale outage. Somebody who can actually coordinate all the different teams, all the different engineers, and make sense of what's happening and who's doing what. Let's talk about escalation paths. When something goes wrong and you're the first person to respond, or you are the primary on call, it's very common for you to get stuck. Who you reach out to and under what conditions is what an escalation path is. So if I'm the first responder and I discover that there's a database issue, but it turns out I'm not a database expert, I know who I can reach out to. That would be my escalation path. One of the other nice things about a proper on-call procedure is having alerting policies. I can tell you personally, I'm not going to wake up to an email telling me that something's wrong with our systems. In fact, I may not even wake up to a text message. What I'd actually prefer is a phone call. So being able to customize how I'm alerted is part of a really good incident response plan as well. And when I am alerted, I want to make sure that I'm not just told something is broken. I need some kind of context. I need you to tell me, are customers impacted? What parts of the system are experiencing issues? And what can I use as a starting point to go in and understand more about the problem? Another great part of a really good incident response plan is having something in place for your rotations and your handoffs. As engineers go off call and others become on call, it's important for them to share ideas and share information about what has been happening during their on-call responsibilities so that you can pass that information on. Another area that's super helpful for incident response plan is actually to practice. We call these game day exercises. So what you do is actually stage a rehearsal for some sort of a problem. If you're going to get good at understanding when things are broken and how to respond to them, it's something that you do have to rehearse and do have to practice. So I suggest you go through and every once in a while, maybe every quarter, a couple times a year, you set aside some time to actually look at your incident response plan and see what you can do to improve it. A big part of every company is prioritizing where their energy and where their efforts go. So to leave you with a few tips for this incident response plan, here's what I suggest. First of all, most of this is about preparation. There's so many things that you need to be doing ahead of time before problems emerge. Responding to incidents is much better than reacting to incidents, so we need to be able to prepare for things. Prioritizing for failure will help us understand that things are going to go wrong. We need to have some procedures in place. We want to always focus on everything we're doing within the system is providing more observability. Observability of a system means that not only do we know something is wrong, but we know how to ask what is wrong, and we can get into the details of what actually needs to be recovered. Okay, so here's some tips for creating an on-call response plan. First of all, you need to set up your roles and rotations. Those would be our primary on-call, our secondary on-call, and possibly, if it makes sense, an incident commander. We also want to make sure that when we alert and we tell people and we tell software engineers that something's wrong, that we're providing contextual alerting. We're giving them a starting place, something that can actually help them make a difference with this incident. And last, you need to focus on escalation paths. When engineers ultimately get stuck, they're not really sure what the next steps are, it needs to be very explicit on who they should reach out to. I also want you to focus on creating routine. The on-call handoffs, the briefings between engineers as they go on-call and off-call are very, very helpful for sharing information about what's going on with the system. That needs to become a routine. The next thing too is, like I said, we need to rehearse our incident response plan. If we never do and we only do these things when something goes wrong, it's not going to go very smooth. A lot of this, as you can probably imagine, is really about continuous improvement, which is at the heart of the DevOps community and even SRE. We know that there's lots of different ways you could be doing this. I provided you with a little bit of a roadmap for building just the minimum ideas about an incident response plan, but I highly recommend that you go out and just implement something and then continuously improve on that. I thank you for your time today, and hopefully I've given you some tips so that you can build your own minimum viable incident response plan. Thanks.